Question 1. 23 over 100 as a decimal is 0.23. 0.7 is 7/10, which is 70 out of 100. So as a percentage, that is 70%. Part C, 1/5 is 2/10. So as a decimal, that is 0.2. Part D, 75% is 3/4. So if you've got 8 triangles, that's 6 out of 8 triangles. So 6 have been shaded. Part E, 21% of the people are asleep, the rest are not asleep. So you take the 21% away from 100%. 100 take away 21 is 79. Question 2. So AI, how can we best describe the chances of landing on a red? Well, the reds are 5 out of 6. So when you spin this, the likelihood of landing on a red is pretty high. So that's likely. Now part 2, chances of landing on a blue. Well, that's impossible. There aren't any blues, so impossible. Now for part B, 3 of the balls are green. That's 3 out of 10. So that's 3/10. So we need to do X marks the spot, 1, 2, 3 along. Question 3. So a couple of ways to do this, but the way I've done it is to work out how many packs we've got. So we've got 150 buns, but there are 6 buns in a pack. So to work out the number of packs, I've done 150 divided by 6 to give me 25 packs. Now each pack costs £1.03, 25 packs in total, so 25 lots of £1.03 gives me £25.75. Question 4. Well, 4m plus 2m is 6m. Then take away an m from 6m, we get 5m. Part B, simplifying 5p times 7. Well, this is 5 times p times 7, or 5 times 7 times p. 5 7s are 35, so that's 35p. Now part C, to undo this timesing by 8, we divide by 8. So G is 40 over 8, which is 5. And you can check your answer. 8 5s gives us 40. Now for part D, what number when we take it away from 19 gives us 4? Well, that's 15, because 19 take away 15 is 4. Question 5. Well, this says to draw a suitable diagram. There are a number of diagrams allowed, but I think the most sensible one to do is a bar chart and then just have different bars, so do a dual bar chart. So I've chosen to do my London ones in red and my Cairo ones in purple. So I've just set up my y-axis for temperature to go all the way up to the biggest temperature, which is 28. So one square fitted nicely for that. And then along the bottom, I've just spread it out nicely. So I've just chosen to make each bar to be 2 squares wide. Then I've left a gap between my January, my April, my July and my October. So for example, for January then, for London, which I've done in red, I've gone up 5 squares, so we've gone up to 5. And January for Cairo, so still in January, but Cairo in purple, I've gone up to 14. So we've got sort of pairs of bars, so it's a dual bar chart. We've got a London and a Cairo for both January, April, July and October. Question 6. So we're throwing a dice, a 6-sided dice, and we're also spinning a coin that can land on heads or tails. So all the various combinations, well, we could throw a 1 with the dice and have a heads or a tails, a 2 with the dice and have a heads or a tails, and so on. So there are 12 possible combinations. All of those have to be listed. Question 7. Now the key bit here is to get the mirror line correct. The line is y equals 1. Now that is parallel to the x-axis, okay? All of the coordinates on this line have a y coordinate of 1. So make sure that is your mirror line. You've not done a vertical one. Now once you have that, it's easy enough just to reflect it. So that point is 1 away from the mirror line, 1 away here. This point is 1, 2, 3, 4 away from the mirror line. So 4 away behind the mirror and so on. Question 8. So 19 over 5 as a mixed number is 3 4/5. You can do that on your calculator to check. Now part B, what fraction of the animals are cows? So let's first of all work out how many cows we've got. 10 horses, 45 sheep, 84 in total. So 84 take away 10, take away 45 gives us 29 cows. So as a fraction of the total animals, that's 29 out of 84. Now for part C, I think the easiest way to do this, and to be sure, is to turn each of these fractions into decimals. So these are the approximate decimals for those four. They're then easy to sort of put in order from smallest to biggest, smallest, second smallest, third smallest, fourth smallest, and then of course make sure your fractions are your final answer. So 1, 2, 3 and 4. Now for part D, to take away fractions we need a common denominator. So we're going to just focus on the left hand side, do the maths and make sure that we then show that the answer is the right hand side. So just focusing on the left hand side, 23 over 24 can stay as it is because we can have a common denominator of 24. So the second fraction I choose to multiply top and bottom by 3, making 9 over 24. Now that I have a common denominator, I can subtract the numerators. 23 take away 9 is 14. That's 14 over 24. Now we can simplify this by halving top and bottom, giving me 7 over 12, which is what I had to show. Question number 9. So how many fish can we fit into this water? So let's first of all work out the volume of water. So to work out the volume of water, obviously I know the base is 55 by 28. Now the height of the water is 30 because it's 3 off the total of 33. So the volume of water is 55 times 28 times 30, which is 46,200. Now that's the amount of water I've got. Now let's focus on each fish. Now each fish must have 4 litres of water. Now big learning point, 1 litre equals 1,000 centimetres cubed. So 4 litres, the amount I need for each fish is 4 lots of 1,000, which is 4,000. So I need 4,000 for every fish, and I've got 46,200. So how many fish can I fit in? Well, it's 46,200 divided by the 4,000, which is 11.55 fish. Now be ever so careful here. The temptation is to round up, but we can't fit 12 fish into this and follow the rules. So even though this is bigger than 11.5, we have to round down and say our final answer is 11 fish. Question 10. So part A, write down the ratio of elephants to giraffes. So elephants has got degrees of 150. Giraffes is 75, so that's the ratio. In its simplest form, we can divide both by 75, giving us 2 to 1. Now for part B, we're using the fact that Jerry saw 8 lions. So the lions is 40 degrees. Now this represents 8 lions, 8 animals. So 40 degrees is 8 animals. So how many degrees for one single animal? Well, we have to divide both by 8. So we can see that one animal is represented by 5 degrees. Now for the giraffe, we can see this is represented by 75 degrees, but it's 5 degrees for every animal. So we have to do 75 divided by 5, so 15 giraffes. Now for part C, we've got to be ever so careful here. Yes, Leslie saw a higher number of degrees of elephants, so the proportion of elephants she saw is higher. That's true, but we just don't know what the actual values are involved for Leslie. I mean, she might not have seen very many animals at all in total, so it might be 190 degrees worth, but it might be 190 degrees of not many animals. So our answer has to be that we just don't know. As the pie chart shows proportions, we do not know the actual numbers for Leslie. The pie chart represents proportions, it does not represent actual values. Question 11, part A. Well, we start by subtracting 7 from both sides, so 5m equals 17. We then divide both sides by 5, so m equals 17 over 5. That's fine as the final answer, but if you've given it as 3 2/5 or 3.4, that's fine as well. Now for part T, we need to make T the subject. So we start off by undoing this dividing by 2. So 2k equals T minus E. Now we want to end up with T on its own, so we need to undo this minusing of E by adding E to both sides. So T equals 2k plus E. Now part C, just one of the index laws. When we're dividing, we subtract the powers. So it's P to the power of 5. Now part D, anything to the power of 0 is 1. So if you're in a test and you wanted to just check, just take any number you like. Say for example 7, pop it to the power of 0 and you're going to get 1. Now for part E, I would work my way along applying the cubing to each of the 3 components. So we've got 3 being cubed, x squared being cubed, and the y to the power of 5 being cubed, and then just gather your thoughts. Now 3 cubed is just 3 times 3 times 3, which is 27. Now where we have a situation like this, that we have a power inside the bracket and a power outside the bracket, we multiply these 2 powers together. So 2 3s are 6. So it's x to the power of 6, and similarly 5 times 3 is 15, is y to the power of 15. Question 12. So for part A, we've got to work out the circumference of the circle. So hopefully you've learnt cottage pie's delicious, apple pies are too, or something similar. Now on this particular question, we're working out the circumference, so we can forget the area formula and just focus on circumference equaling pi times diameter. Well, pi is pi. Now the diameter is twice the radius, so 2 lots of 9 is 18. So the circumference is pi times the diameter of 18, which is 56.548, which to 1 decimal point is 56.5. Now for part B, we've got to work out the perimeter of this shape, so that's the length all the way around the outside. Now we're told the area of the square is 169. Now the area of a square we get by doing base times height. So the base times the height, a number times itself, has to be 169. So these 2 lengths must be the square root of 169, which is 13. Because 13 times 13 gives us an area of the square of being 169. So we know these lengths around the square are all 13. Now we're also told that ABE is an equilateral triangle. So these 3 lengths in the triangle are all equal. So these lengths AB and AE are the same as BE, which is 13. So these lengths are also 13. So the perimeter, the length all the way around the shape, is just 5 lots of 13, which is 65. Question 13. Now, be very careful that you give a reason for each stage in your working. You will not get full marks if you don't. So, working our way around this, the first thing I've focused upon is this triangle ABD, which is an isosceles triangle. Now with an isosceles triangle, these base angles are equal. So how do we work out these? Well, I did the angles in a triangle being 180, take away the 48, which is 132, then split that equally between these 2 angles by halving it. So that angle there, angle ADB, is 66 degrees, and the reason is base angles of an isosceles triangle are equal. The next angle I worked out was this pink one, and I've done that by just taking the angles about the point here. Angles about a point add up to 360. So this angle here in pink must be 360, take away the 243, take away the 66 that I've just worked out, which is 51. So angle BDC is 51 degrees because angles about a point total 360 degrees. Now I can now work out, or I could anyway, I could have worked this one out first if I wanted. I can work out this angle here, angle DCB, because angles in a straight line add up to 180. So this angle must be 180 minus 68, which is 112. And as I said, the reason is angles in a straight line total 180. So I now know that this is 51, this is 112. So the y must be 180, take away 51, take away 112, which is 17. And the reason is angles in a triangle total 180 degrees. Question 14. So we're told 300 cars are made per hour and the cars are made for 9.5 hours each day. So how many cars are made each day? Well, it's 300 times 9.5, which is 2,850 cars per day. Now we're told that 8% of these are faulty. So how do we work out 8% of 2,850? Well, 8% is 8 out of 100. So just pop into your calculator 8 over 100 times 2850, and that tells us that 228 are faulty. Now if 228 out of the total of 2850 are faulty, the rest aren't faulty. So we do 2850 take away 228 to work out that 2,622 cars are not faulty each day. Question 15. So a perpendicular bisector. Perpendicular means we need to draw a line which is at 90 degrees to AB, and bisector means it goes smack down the middle. Now the point is we've got to use ruler and compasses only, so you can't just measure along here then get out a protractor and measure 90 degrees. So how to do this? You get your compass and you go and put your pin here and make the arc length about there. So just sort of get the pencil point about there, and you just do a nice big arc. So that first one in pink will be my first arc. Then without changing the width on your compass, go and put the pin over on B and do a second arc over there. Now where these two pink construction lines cross is where you go and join together. So using your ruler, your final answer is this blue line going through where the two construction lines cross. And this blue line is halfway along and is at 90 degrees as required. Question 16. So the modal class is the class where something happened most often. Well, what happened most often? Well, on 16 occasions, the number of birds that people counted in the morning was between 11 and 15. So 16 is what happened most often. What happened on 16 occasions? The number of birds seen was between 11 and 15. So when I ask for a modal class, you've just got to copy down which of these you think is correct. Well, it's the 11 to 15. Now for part B, we've got to work out an estimate for the mean number of birds. Now to really get behind this, you need to understand what this is telling us. This table is telling us that 5 people saw between 1 and 5 birds in the morning. Okay, now how many birds did they see? We just don't know. It might have been 1, it might have been 2, 3, 4 or 5. So the best we can do, and the reason it's an estimate, is to take the midpoint, is to take the halfway point. Now the easiest way to work out the midpoint, if you just can't just see it, is to work out the average of these two numbers. So 1 add 5 is 6, half of 6 is 3, and so on. So the midpoint between 6 and 10 is 8, or if you need to do it, 6 add 10 is 16, half of 16 is 8. So we basically get 4 midpoints. Now from now onwards, we're going to pretend that's exactly the number of birds that was seen each morning. So we're going to say 5 people saw 3 birds, 10 people saw 8 birds, and so on. So how many birds were seen in total? Well, 5 people saw 3 birds, that's 15 birds. 10 people saw 8 birds, that's 80 birds, and so on. So we cross multiply. 5 times 3, 10 times 8, 16 times 13, and so on, giving us these 4 subtotals. We add these up to get 465. So 465 birds were seen altogether. Now be careful, you need to divide that by the 40 people. Do not be tempted to divide it by the fact we've got 4 rows. You've got to divide it by the 40 people, giving us an answer of 11.625, and do not be tempted to round this. I know it's an estimate, but it's only an estimate because of this assumption you had to make at the beginning. Do not round your answer. Question 17. Now this is tricky, I thought. So we're told the ratio of red counters to blue counters is 2 to 13. So 2 to 13, how many counters is that in total in the ratio? We've got 15 shares in the ratio. That's the bit in purple. Now we're told there are 90 counters in the bag altogether, so that's fine. So 90 bags. So 90 counters rather. So 90, we've got to consider the 90 total versus the 15 ratio total. So how do we scale this up? How many times bigger is 90 than 15? Well, do 90 divided by 15 and you see that it's timesing by 6. So to maintain this ratio, we're going to multiply all of these numbers by 6. 2 times 6, 13 times 6, and we've got our 15 times 6 already. So that means we have 12 reds, 78 blues, giving us a total of 90 counters to start with. Now, we're told that once Lee puts some more red counters in the bag, the probabilities of taking a red counter is 1/3. Now, you've got to be careful here. If the probability of getting a red is 1/3, then the probability of getting a blue must be the rest, which is 2/3. So how much bigger is the chances of getting a blue? Well, it's twice as big, 1 to 2. So we need to have twice as many blues as we've got red. So we've got 78 blues. Now we need to have half as many reds. So we need to end up with half of 78, which is 39 reds. Well, we've presently got 12 reds in the bag. We need to get to 39 reds. So how many reds do we need to add to the bag? 39, take away 12, which is 27. Question 18, so we need to draw a Venn diagram to show this information. So we have two rugby ball shapes overlapping, which are A and B. So let's go and start off filling in the middle first of all. A intersection B, so the numbers that are in A and B are 1 and 3. So I've started off by putting 1 and 3 in the middle. Now the next thing I've done is to focus on the fact that A is all the odd numbers. So all the odd numbers need to be in the rugby ball A. So working along through the odd numbers, number 1 we've already included an A, it's in the middle. 3's odd, again we've already included that in the middle, so it's already an A. So the other numbers that need to go into A are the other odd numbers, so 5, 7, 9 and 11. 5, 7, 9 and 11. So I've got the ones in the middle, I've got the rest of A, and now I'm going to go and focus on these numbers over here. So A union B is this list of numbers. Now union means that the numbers are either in A, or they're in B, or they're in both. So I need to have all these numbers here stretched across the two rugby balls. So working my way along, 1 I've already got in the middle, 2 I need to have, so let's go and pop that in B. 3 I've already got, 4 I need, so I put 4 here. 5 I've already got, 6 I need, so I pop 6 in. 7 I've already got, 9 I've already got, 11 I've already got, and 12 I need, so I pop the 12 there. So those are all the numbers that are in A and B. Now these are all the numbers in total that have to be somewhere in my rectangle. This is my universal set. These numbers here have to be somewhere in the rectangle. So far I've included all of them apart from 8 and 10. So 8 and 10 have to be outside A and B but inside the rectangle. Question 19. Now this was also pretty difficult, I thought. So let's kick off by just choosing to make the length of each of these rectangles X and the width of each of these rectangles Y. And then we can just construct a couple of equations. We know this whole length here is 67, so X plus Y must be 67. So 2x plus y equals 67. That's my first equation I constructed. Now looking across this row at the bottom, x plus x plus x plus x plus y must be 123. So that's 4x plus y equaling 123. So I've constructed these two equations. Now they've got the y in common, so I can choose to subtract the bottom one from the top. 4x take away 2x is 2x. Y take away y is nothing. That's what I wanted to do. I've eliminated it. And 123 take away 67 is 56. So 2x equals 56. Halving this, x equals 28. So the length of x is 28. Now to work out y, I can just substitute back into either of the equations. And I'm going to choose to use 2x plus y equals 67. Now I've just worked out that x is 28. So 2 lots of 28. Add y equals 67. 2 lots of 28 is 56. So 56 add y is 67. So y is 67 take away 56, which is 11. So I've now worked out the length and the width of each of these tiles. So let's just go and start thinking about the area of the grey bit, which is what I need to work out, the shaded area, the shaded rectangle. So let's start off by working out the area of the whole shape. So that's obviously the biggest rectangle there, 123 times 67, which is 8241. So just park that for now. Now the area of each of these tiles I can now work out now that I know x and y. It's just base times height, x times y. That's going to be 28 times 11, which is 308. So each of these tiles has an area of 308. There are 12 of these identical tiles, so the area taken up by this frame, if you like, is 12 lots of 308, which is 3696. So the area inside, this shaded area, has got to be the total area, 8241, take away the area of this white frame, which is 3696, giving us this inner rectangular area of 4545. Question 20. Now I think the easiest way rather to work out the highest common factor is to do a number tree, a product of prime factors for both of these numbers. So I've just done the number tree for the 96, getting 2 times 2 times 2 times 2 times 2 times 3, and then also for the 120, getting 2 times 2 times 2 times 3 times 5. Now the highest common factor is what I get when I multiply the numbers together that are on both lists. So I've got the 2, 2 and 2 in common. So that's the 2, 2 and the 2, and I've also got a 3 on both lists. So I've got a 2, a 2, a 2 and a 3. Now when I times all of these together, I get the highest common factor of 24. Now for part B, when you're trying to work out the lowest common multiple of 3 here, and it's already in prime factor form, what you need to do is multiply together the biggest one of each. So we need the biggest number of 2's, the biggest number of 3's, and so on. So what's the biggest number of 2's we've got? Well, it's 2 to the power of 4. What's the biggest number of 3's we've got? Well, it's just this 3 on its own. What's the biggest number of 5's anywhere? Well, it's this 5 squared. Biggest number of 7's? Well, it's this 7 squared. And then we've got the biggest number of 11's is just an 11. Doesn't matter which one, it's just 11. So get your calculator out, multiply all of these together, and you get 646,800. Question 21. So, you just really need to learn the process, I think. The first number is the 8,500. Now, we're going to multiply this by the multiplier. Now, given that we've got a 2.3% compound interest, our multiplier is going to be 1.023. Had this been 5%, we'd have used 1.05. Had it been 4%, we'd have used 1.04. But it's 2.3, so we have to use a multiplier of 1.023. Now the power is the number of years, so that's 3 on this occasion. So get out your calculator. 8,500 times 1.023 to the power of 3 gives us 9,100.09. So to the nearest dollar, that is 9,100. Question 22. So let's first of all get a formula to use. So we know that density equals mass over volume. If we multiply both sides by V, we get mass equaling D times V. Then if we divide by D, we get volume being mass divided by density. So our mass is 3.5 divided by our density of 0.65 gives us 5.3846 ... So to 3 significant figures, remember that just means 3 numbers in total, that's 5.38. Now for part B, you just need to carefully work through the changes. So we've got 630 kilometers per hour. So let's start off by changing this into meters. Now there are 1,000 meters in a kilometer, so times 630 by 1,000, you get 630,000 meters per hour. Now, how far would we go per minute? Well, that's not going to be as far as we can go in an hour, is it? There are 60 minutes in an hour, so we have to divide this number here by 60. So we've got to 10,500 meters per minute. Now we need to turn this into seconds. Now again, we're not going to go as far in a second as we are per minute. We're going to have to make it smaller. How many seconds in a minute? There are 60. So divide the 10,500 by 60 and we get 175 meters per second. Question 23. So To solve one of these, we need to line up either the x's or the y's. Now I'm choosing to line up the x's by doubling the equation number 2, because I'm then going to have 4x's in both. If you'd wanted to, you could have times the second equation by 5 to line up the y's, but I'm going to focus on the x's. So I'm taking equation number 2 and I'm doubling everything. Doubling this, doubling this, doubling this. So I get 4x minus 2y equaling 18. So I've got my 4x. Now line that up with equation number 1, the 4x plus 5y equals 4. Got my 4x's lined up. Now because these both have the same sign, to eliminate it I need to subtract this equation from the top one. So 4x take away 4x is nothing. It's eliminated. Minus 2y minus 5y takes me to minus 7y. Be careful there, think about the number line. Minus 2 minus 5 is minus 7. And then finally 18 minus 4 is 14. So minus 7y equals 14. Divide both sides by minus 7, we get y equaling 14 over minus 7, which is minus 2. So y is minus 2. Now to work out x, I substitute this minus 2 into whichever equation takes my fancy. So I'm going to take the top one, the 4x plus 5y equals 4. So substitute in the fact that we now know that y is minus 2, y is minus 2. So 4x plus 5 lots of minus 2 is 4. 5 lots of minus 2 is minus 10. So 4x minus 10 is 4. Add 10 to both sides, divide by 4, we get x equaling 7 over 2, or 3.5 if you prefer. Question 24, not too bad a question to finish, I think. So when you're given a diagram like this, and you've got a straight line on it, you need to find an equation. Really, your go-to starting point has got to be think about the equation y equals mx plus c. So that really gives us a skeleton to build upon. Now m is going to be the gradient, the slope, we'll come back to that in a minute. C is where the line crosses the y-axis. So just make sure you start off by picking up that easy mark. Where does this line cross the y-axis? Well, it crosses here at +1. So just go and put +1 down in your answer just to pick up the opening mark. We now need to focus on working out m, the gradient, the slope. So how do we work out the slope? Well, you take a triangle of your choice. Now keep things simple. Just make sure the triangle is going to comprise whole squares like mine does here. Now how do we then work out the slope? Well, we have to divide the height of the triangle, that's called the y-step, by the base of the triangle, that's called the x-step. Now obviously that's 3 squares and that's 2 squares. 3 divided by 2 is 1.5. So that is my slope. That is my gradient, that is my m. So my final answer is y equals 1.5x plus 1.